The material that this presentation is based on comes from the second edition of IFSTA's self-contained breathing apparatus manual. So if you want to know more about this subject, refer to this book. Breathing apparatus in the fire service comes in two broad categories. There's open circuit and closed circuit, and we'll show you both during this segment. We have before us several examples of open circuit backpack type units, which are by far the most common. It should be pointed out, though, that whatever type breathing apparatus your department uses, it should be of the positive pressure type, because any leak that occurred in the older demand type would allow airborne contaminants to enter the system. The older demand types that may still be in use can be converted to positive pressure for a very small charge. Let's start with the backpack type open circuit breathing apparatus, which, as I said, is the most common type in the fire service. We have several examples here. We have a Scott, an MSA, an Interspiro, and a Draeger, and there are other brands, and they're all equally good. These units come in two basic sizes, a half-hour type and a 1-hour type. The half-hour units contain approximately 45 cubic feet of breathing air at about 2,200 psi. The 1-hour units contain about 88 cubic feet of breathing air at about 4,500 psi. However, you must remember that those are maximum rated capacity, and in actual work you can't count on getting that amount of time out of any particular cylinder, especially when you consider that you're going to be using them under load, and firefighters walking upstairs in full turnouts with the weight of the breathing apparatus on them, carrying extra equipment, are going to be exerting themselves considerably. And so they're going to be using up the air at a pace faster than when these were rated. So on the open circuit devices, the time rating is only the maximum possible and is not what you're likely to get out of it. Another difference between these types of breathing apparatus are the materials from which the tanks themselves are made. Some are steel, as in this case, and others are composite, and there's aluminum and composite and a number of other combinations. And those vary in the weight of the units. All of these units have certain components in common. They all have some sort of backpack and harness arrangement. They have a cylinder and valve assembly, and they have a regulator assembly that's either mounted to the harness, as shown here, or, as in this case, the regulator mounts directly on the facepiece. The harness and backpack unit's purpose is to hold the unit on the user, obviously, but also to distribute its weight properly so that it reduces fatigue. The cylinder holds the air supply, and there's also a gauge attached that allows you to see how full the tank is filled. And there's either one or two hoses that transport the air from the cylinder and valve to the regulator and then to the facepiece. The regulator's function is to reduce the air pressure from the pressure in the tank to slightly above atmospheric pressure for the user. Finally, each unit has a facepiece that will consist of some sort of clear plastic lens and some sort of mounting device. In this case, with the facepiece mounted regulator type, they have a hairnet device that holds the unit onto the user's head. On this type with the regulator mounted, with the harness mounted regulator, they have a low pressure hose from the regulator to the facepiece, and the facepiece is mounted in a rubber face mask with another harness attached to that holds the mask snugly to the user's face. Now, it should be pointed out at this time that to use these effectively, facial hair, even a modest beard such as mine, should not be allowed if it interferes with the facepiece seal, because if that seal is compromised in a positive pressure unit, it won't allow contaminants in, but it will allow air to escape, and that will significantly reduce the working life of each cylinder. There's also the tank and valve assembly. The tank, which of course contains the breathing air, and the valve assembly, which consists of the control valve, the pressure gauge showing the pressure of the air in the tank, a low pressure alarm, and the high pressure hose that leads to the regulator. The regulator, in this case a harness mounted regulator, its function is to reduce the air pressure from the tank pressure to slightly above atmospheric pressure for the user. This type consists of the pressure regulator itself, a gauge that also shows the remaining pressure in the tank, and two control valves. There's the bypass valve and the mainline valve. They are of different colors and shapes so that they're easily identified in the dark or in smoky atmospheres. The mainline valve is normally open during operation, and the bypass valve is closed. The bypass valve is only used if the regulator malfunctions, and this allows you to use air directly from the tank. On this type, with the facepiece mounted regulator, there may only be the bypass control valve. Remember that the half-hour and 1 hour capacity ratings on these units are maximum capacities, and the factors that will determine how long they will actually last under actual workload are the physical condition of the user, the degree of physical exertion that the user is expending, the emotional stability of the user, is he excited or frightened, the condition of the SCBA, is it in good condition or does it need maintenance, the pressure that was in the cylinder before the operation started, and finally, the user's familiarity with the SCBA based on his training and experience. The other type of open circuit breathing apparatus used in the fire service is the so-called airline unit. And it's called that because instead of having a cylinder on the user's back, the unit connects to an airline that supplies air from a remote location. And the airline can be up to 300 feet long. These units are ideal for extended operations such as you might have in a hazmat spill or in some extended rescue operations. They have the same basic components as the backpack units without the backpack. In addition, they have a small 5-minute escape cylinder. This cylinder is designed to give the user 5 minutes of breathing air to use to escape if the air supply is interrupted. Otherwise, the regulator is a standard facepiece mounted regulator, as similar to the ones on the backpack. The other major category of breathing apparatus used in the fire service are the closed circuit self-contained breathing apparatus. They are called closed circuit because the exhaust air, rather than being expended into the atmosphere, is contained within the unit, is recirculated through it, and rebreathed by the user. There are some similarities and some differences with the open circuit units. The similarities are that they have a backpack. In this case, it's the rigid case of the unit. They have a harness, just as the others do. They have a face mask. But one of the differences is that this unit has two low-pressure hoses. One's an inflow hose and one's an outflow hose. Inside of the unit, you can see that this part contains the filter medium that when the expended air passes through, this filters out the carbon dioxide and the moisture. It's then re-oxygenated from this small oxygen cylinder, and then it goes into the rebreather bag from which the user draws the refreshened air. The advantages of this type of unit are that pound for pound, they have a lot greater useful life than the backpack units. Another major difference between the closed circuit units and the open circuit type is that the rated capacity of the closed circuit types is the minimum rather than the maximum useful life of the unit. So a 4-hour unit in a closed circuit, you can expect to get a full 4 hours of operation out of it, regardless of the amount of work that the user's doing. One other difference between this unit and the open circuit types is that after each use with this type, the filter medium and the oxygen cylinder have to be replaced before it can be placed back in. Contained breathing apparatus is routinely subjected to rough handling during fires and other operations, to a lot of excess moisture, and to other hazards on the scene. Whenever the unit has been used, it needs to be thoroughly inspected and cleaned before it can be reused. After filling 2 clean buckets or pails about 2/3 full with warm water, the firefighter adds the amount and type of cleaner disinfectant that's recommended by the manufacturer to one of the buckets. It then disconnects the facepiece assembly from the regulator. He inspects the facepiece assembly, starting with the lens, looking for cracks or deep scratches in the lens. Next inspects the mask itself for cuts or punctures or burns to the mask or the strap. They make sure all the straps are fully extended. Next, he inspects the low pressure hose, stretching it out so that he can inspect the corrugations. Again, he's looking for cuts, punctures, burns. Next, he takes the facepiece assembly to the deep sink and starts with a rinse to remove the large particles of debris. This can be done under a faucet or with a garden hose. He then immerses the facepiece assembly in the cleaning solution. Agitates it enough to get the cleaning solution through the entire assembly. One part of it is making sure that water flows through the exhalation valve. He does that by pressing on the exhalation valve inside the mask with his finger. Next, he moves the entire assembly into the other bucket for the rinse. He agitates the unit in the water sufficiently to make sure that the rinse is thorough. In removing the unit from the water, he dumps all the water out of it that he can, stretches out the low-pressure hose so that the water drains from the corrugations. And then, using a soft, clean cloth, wipes the excess water from the facepiece assembly. Once the facepiece assembly has been grossly dried with the clean cloth, it's then taken to be hung up to air dry. Next, the firefighter wants to check and clean the rest of the SCBA unit. First, he starts by inspecting the harness to make sure that it's clean, that it's free of cuts, burns, or excessive wear. And wear will show up in the form of fuzzy spots on the surface of the straps. He makes sure that all the buckles work properly and that the straps are fully extended. If the harness needs cleaning, he'll wash it with a mild soap or commercial cleaning agent and rinse it and allow it to air dry. Next, he'll inspect the regulator. He checks it for damage, make sure that the gauge lens is not broken or scratched, and that there's no moisture inside the gauge. He opens and closes the control valves, leaving them in the closed position. Next, he inspects the cylinder and the cylinder valve assembly. He wants to make sure that there's no obvious damage to the cylinder or to the valve assembly. He wants to, again, check this gauge to make sure that the lens hasn't been damaged and that there's no moisture inside the gauge. He checks the gauge finally to make sure that the cylinder has a full charge. When all of the parts are dry, the unit is reassembled and tested, and if everything works correctly, it's stored for use next time.
The idea is to get the point across to you, the firefighter, the importance of taking care of your equipment. You can see that maintenance is going to be a very detailed, arduous task. At least every other year, SCBAs should be brought into a maintenance facility and completely tested by a qualified maintenance technician. This requires that the SCBA be completely disassembled, all of the hoses removed and tested, not to mention the backpack assembly tested and the strapping material. The regulator is the most sensitive, delicate part of the apparatus. Firefighters are cautioned time and again not to drop their regulator, not to abuse them. Yet, in many firefighting situations, it's unavoidable. Today, we're looking at taking a peek at the maintenance requirements of testing regulators. Background, we have a technician that will be doing the biannual testing. The regulator assembly that he's working on was a high pressure to low pressure block. Must be completely removed from the backpack. Has to be connected to an air supply and with the addition of testing equipment supplied by the manufacturer, he must go through and check to see that it allows the firefighter proper pressure, proper flow for breathing, make sure that the valving opens and closes inside of the unit. Once he's tested the primary regulator, he has to test the secondary regulator, has to put the entire unit back together and test it again. So that it goes through at least 3 sets of tests. This is a very time-consuming, delicate operation. If there is no malfunctions, if the unit requires no repairs, looking at least an hour for technician to take a unit apart, test it, and put it back together. If any repairs are required, unit will take it up to 2 hours to be tested and properly repaired. During this time, there's a detailed set of records that are maintained for each unit. A unit that is taken apart must have all of its pieces kept with that particular unit. Some departments go as far as numbering the cylinders, the regulator assemblies, the backpacks, and the face pieces to make sure that they keep all of the pieces with the unit as it was purchased. Any additional or extra parts or non-standard parts attached to the unit or parts that have been mixed in from other manufacturers could void the warranty of the unit and possibly void the certification.
For changing an air cylinder without removing the backpack. The firefighter comes from the fire and returns to the engine needing an air bottle change. The firefighter at the engine checks the cylinder valve to make sure that the cylinder is turned off. Next, he disconnects the high pressure hose. He releases the cylinder band, pushes the empty cylinder up and out of the backpack, and replaces it with a full cylinder. Make sure that it's all the way down in the backpack and retightens the cylinder band. Then reconnects the high pressure hose. He then turns the cylinder on. And listens for any air leaks. Hearing none, the firefighter is ready to re-enter the fire.
In order to maintain accountability for firefighters, a firefighter should be posted at the entrance of a building, take the name of the firefighters that are entering, take a pressure reading off of their air cylinders, and note the time of entry. This way, any firefighters that are in the building for an extended period of time, or if the incident commander later sees that he's lost some personnel, you have a arrangement to track those people and determine how long they've been in. The record-keeping individual at the door should also make notes of usage, air usage, so that later on he can make an estimation as to when these people should come out, when the firefighting team should return. This is a discussion of buddy breathing techniques. In the past, we've discussed some antiquated techniques and taught these to firefighters. Previous techniques are no longer in use nor promoted by most training agencies throughout the fire service. Today, the only legal and safe methods are those that use buddy breathing equipment, something that does not break the seal around the face piece for the firefighter. It keeps him in an atmosphere that is safe and allows him to have safe breathing air. Several companies today offer such equipment or adaptations to their breathing apparatus. These firefighters will now show us how a Scott unit designed for buddy breathing works. Firefighter is out of air, and suddenly he'll make a quick connection to his partner. At this time, they're breathing off of the same cylinder, and they leave the scene immediately. They do not stop. They do not continue firefighting operations. They leave the scene immediately. Today's standards, the firefighter can leave absolutely much faster than he could have stopped, shared face pieces, or done any of the operations that were promoted in the past. It's very short, very quick. One firefighter connected to the other. They remain in teams. They leave the scene immediately when one of them has trouble. Both the firefighter in trouble and his buddy. So they travel in pairs, a team operation. If you'll notice that when they did their hookup, they had some difficulty with gloves on, and we'll now show you the close-up of the connections to show you the difficulties of making the connections. This particular model shows a degree of difficulty in disconnecting. You can see that with gloves on or in the dark, it would be very difficult to even disconnect and then to reconnect. The firefighter, again, has to line up a connection, a pin here. This must be lined up precisely before this coupling can slide backwards, and then he inserts the male end into the coupling and he twists it back to lock it. Now it cannot come unlocked, and they can make their escape to the outside. You can see that this takes dexterity and is difficult enough to do without gloves on. So a firefighter must practice this regularly to be able to do it in the dark, automatically and quickly. Just to recap buddy breathing techniques and emergency conditions breathing. Remember, we're no longer condoning throughout the fire service buddy breathing techniques that endanger the firefighter or misuse equipment. Today, manufacturers create, design, and build equipment that will support buddy breathing between two firefighters. Methods that expose a firefighter to hazardous atmospheres or anything that breaks the seal of the face piece with the firefighter is no longer a valid method of buddy breathing. We've shown you some equipment and how it can be used to support buddy breathing. There are techniques that can be used to keep the firefighter from getting in trouble in the first place. That is the goal. You train a firefighter in his breathing techniques, called skip breathing. One of the best things a firefighter can have going for him is good physical conditioning. He has to be very comfortable wearing his SCBA psychologically and physically. We post people in front of doors so that they track entry teams. Having a firefighter be able to calculate his air consumption, know his limitations. When that firefighter enters a building to fight a fire, he should know how much air is in his cylinder and have some idea how long it'll last him. Shouldn't wait until the bell goes off to escape. If the bell does go off, he's got his warning time. He should leave immediately, as should his buddy. Firefighters should travel in pairs. You can see that buddy breathing doesn't do any good if there's nobody there.